Let us start the topic of MIMO, which is multiple input and multiple output, that is multiple antennas technologies. So here the generic term MIMO means multiple input and multiple output. It is a technologies using multiple antennas for transmission and reception of multiple radio signals. The name relates to the transmission channel on which the multiple signals are injected via multiple transmitting antennas, which we call as the multiple input, and from which the multiple signals are taken out via multiple receiving antennas, which we call as the multiple output. I mean, there will be multiple n number of inputs to the transmitting antenna, n number of outputs to the receiving antennas. So the minimum multiple input, that will be called as transmitting antennas, and multiple outputs, that will be called as the receiving antennas. So the number of antennas used for TX to RX has to be greater than or at least equal to the number of desired radio signals. Now coming to the multiple radio signals have to be transmitted so that the receiver should be able to differentiate among those radio signals. The signals generated at the transmitter have to be orthogonal. Orthogonality of the transmitted signals is achieved via antenna space diversity and antenna space polarization. Then MIMO capabilities are expressed as number of antennas that can be used for TX multiplied by number of antennas that can be used for RX. When we say that 4T into 2R, that means 4 TX and 2 RX. That means 4 transmitting antennas and 2 receiving antennas. If 4T cross 4R, that means 4 transmitting antennas and 4 receiving antennas. Now coming to the next slide, you see the diagram, how these multiple inputs and multiple outputs. So there are two terminologies here where we will use it. One is the user data stream, another is the radio layer. User data stream means the user data to be transmitted over the antenna, and the radio layer means is the signal generated by the antennas in a way such that allowing to the receiving party to differentiate this signal from other signals. What does it mean? The radio layers. Radio layers means is the signal generated by the antennas in a way allowing the receiving party to differentiate these signals from other signals. You see the first one. You see the first stream. The one number of user stream is 1, number of radio layer is 4. So here the user data stream is 1 and number of radio layer is 4. In the second scenario, it is 4 cross 4, and in the third scenario, it is 2 cross 4. So what does it means? So there are different kind of multiple modes are there: multi antenna mode, user data stream versus radio layers, and then there is a gain. So for diversity, we are using higher reliability. For spatial multiplexing, we are a throughput increase, and for beamforming, we are using the distance increase. So there are different kind of user streams and radio layers. So user streams is nothing but the data to be transmitted over the antenna, and radio layer means it is signal generated by the antenna in a way that would allow the receiving party to differentiate the signals from other signals. So like in the first case, one is the user stream. It goes through 4 different outputs. In the second scenario, 4 inputs and 4 outputs. 4 signals are separated from each antenna so that you will achieve the maximum throughput scenario. The third case is the beamforming scenario. So the first 1:4 which is being shown, that is a case of diversity. The second scenario is the spatial multiplexing, where your throughput will increase because every signal is different, so that to achieve the maximum throughput. The third is the beamforming. So now coming to the diversity. So diversity, which we talked about, the single one going towards the 4 antennas. First, A is a device with a MIMO, which we call as the 4 transmitting antennas and 1 receiving antenna, 4 TR into R. The second, if you see on the right hand side of the slide, A is a device with a MIMO with 1 transmitting antennas and 4 receiving antennas. The case is being talked about 4 TX and 1 RX. The second, the right hand side is showing as 1 TX with 4 RX antennas. So there are different kind of gain elements are present, where we have gain 1, gain 2 and gain 3, which we will talk about in our next slides. So the first is the gain one. The gain due to the propagation via multiple path. You see there is multiple propagation paths are there in the gain one. So where we are going to see the maximum throughput gain. So gain due to the propagation via multiple path. So NT and NR is nothing but number of transmitting antennas, and NR means number of receiving antennas. So a scenario is being explained. The first case is a scenario of 4TX into 1RX. The second case is a scenario of 1TX with 4RX. Now coming to the transmit diversity. The transmit diversity is nothing but the same signal is transmitted onto the multiple antennas. So the gain will be of two different types. The increase in gain can be used for distance increase as well as the throughput increase. So transmit diversity. So here the transmit diversity means the same signal is transmitted to multiple antennas. So that is what we call the transmitting antennas. Now coming to gain 3. So gain 3 is nothing but receiver sensitivity, receiver diversity. Here the same signal received on the multiple antenna gain to the increased received power by factor equivalent to the number of receiving antennas. So increase in gain can be used for distance increase as well as the throughput increase. This is called what we call the receiver diversity. Now coming into the topic of transmit and receive diversity. So what does it indicate? It indicates the same signal transmitted onto the multiple antennas and received on the multiple antennas. Here the multiple gain is calculated as multipath gain plus 10 log NT plus 10 log NR. NT is nothing but number of transmitting antennas. NR is nothing but number of receiving antennas. Here you see a device with a MIMO with 4T into 1R, and B is a device with a MIMO with 2TX and 2RX. So here it is combining the path. I mean it is happening both transmit antennas as well as the receiver diversity. The first one we talk about transmit diversity, second we talked about receive diversity. This is the third one which we talk about transmit as well as receive diversity. This is a concept called spatial multiplexing. What do you mean by? Again, MIMO is divided into two types, SU MIMO and MU MIMO. SU MIMO is single input MIMO. The second one is MU MIMO, multi-user MIMO. So now we will talk about single user spatial multiplexing. You see the single user spatial multiplexing. Here multiple user data streams are transmitted over the multiple radio layers. I mean same frequency, same time, but it will use different processing and polarizations. How we are going to distinguish? The number of different radio layers that the UE is able to distinguish is equal to the rank indicator. What do you mean a rank indicator? It is the value reported by the UE to the base stations, function of UE capability and the radio link conditions. So the radio indicator dictates indirectly the maximum number of user data streams that can be transmitted. Let's say UE reports a radio link indicator of 1. That means only the transmitting antenna, it is signaling, it is only transmitting from one antenna. If Ri is equal to 2, then it will transmit via 2 number of antennas. If Ri is equal to 1, that means only a single radio layer is being processed. If Ri is equal to 2, multi-layer antenna is being processed. So if the multiple layers are transmitted, then they have to carry the same user data stream as UE feels one single radio layer. So always assume that Ri should be 2 in case of a higher throughput. If let's say if you are having 2 antennas and only one antenna is only showing in your system, that means the antenna is only transmitting from one antenna, not from the signal is getting transmitted from one antenna, not from the 2 antenna. Always ensure that there should be, for achieving the maximum throughput, Ri should be 2. Okay. So what is the aggregate capacity? It is the capacity of a user data single stream multiplied by Ri, and multiple path gain stream plus 10 log NT stream plus 10 log NR stream. That is called as the gain, how the gain is calculated. So basically the Ri dictates the maximum number of user streams that is being used in the network. So you see there are 2 inputs. I will show you. So this is nothing but the known elements. One is the transmitting antenna, another is another transmitting antenna. These are the 2 receiving antennas, R1 and R2. When they combine, it gives a signal to R1, it gives a signal to R2. The transmitting antenna is giving a signal to both R1 and R2. Similarly, RT2 is given to R1 and R2. So here it is doing both kind of calibrations. So the known elements are T1, T2 and R1, R2, and the calculated elements are, if you combine this in case of an technological perspective, you will get the combination of both R1 and X1, R1 and T1. Similarly, this for R2 and T1. So this is how our antenna spectral multiplexing will happen. Now comes multi-user spatial multiplexing. So here different signal cells received by the base stations in the same time. BS has the tools to differentiate. So gain per user data stream is equal to 10 log NT stream plus 10 log NR stream. Aggregate throughput is increased. So in case of multiple input, because here multiple inputs are there, but in case of here we are getting only single user. Single user means one transmitting antennas and multiple receiving antennas. But in case of multiple users, 2 transmitting antennas and 2 receiving antennas. But here if you see, the number of transmitting antennas are 1 and the receiving antennas are more than 1. So when we talked about multiple users MIMO, so multiple users MIMO in the DL, so multiple user data stream transmitted by the base stations over multiple radios, same frequencies and the same time frame. So to be able to transmit the multiple user data streams to multiple users simultaneously, need for beamforming to avoid unwanted signal propagation. Sometimes when you transmit all the transmitting antennas to the receiving, like 1, 2, 3, 4 to single receiver antennas, that time there can be a chances that UE will get fall into different unwanted noise and frequency phases. For that, to avoid beamforming is a technique which we will study in our next slide to get more in depth in detail of the beamforming, why beamforming is required when a MIMO is being propagated into the system. So you see multiple transmitting antennas are there and 2 receiving. Here is a case of where 4 TX and 2 RX system. So beamforming. So multiple antennas located at less than lambda by 4 distance. Antennas are fed with the same signal with different phases. Transmission direction is dictated by the phases fed into the antenna elements. We will go in our next topic, what is beamforming, in our next slide, next topic.